Hi and welcome to Audio Keller Special. This is a special amp dyno video because I received a classic MTX caraudio amplifier, the Thunder 2300. That was only possible because a very kind supporter sent this amplifier to me. The amp is rated 150 watts into a 4 ohm load and 300 watts into a 2 ohm load per channel, both channels driven at a voltage of 12.5 volts. And the dynamic ratings are also here. You can see it here on the badge. It's 4 ohms mono, 750 watts of dynamic power. Here are the features of the amplifier. The amp features a Thunder EQ knob where you can adjust a bass boost at 40 Hz with a boost of 18 dB. Then there's a low pass filter built in 80 Hz, 18 dB. And you have a variable high pass or low pass filter adjustable from 50 to 200 Hz with a slope of 12 dB per octave. All resistors on the main board have a tolerance range of 1%. This guy is fused with 3 fuses, 30 amps each. The amp is nicely underrated, and let's check out what the amplifier can do on the dyno.
The MTX Thunder 2300 is connected to the dummy load, and as usual I start with 1 kHz continuous power test. I have connected an 8 ohm load to the amplifier, so I have 4 ohms per channel, both channels driven into full power. Continuous power test, 8 ohms mono. Don't forget the amplifier is only rated 150 watts per channel into a 4 ohm load. Straight up to the clipping point. Wow, high voltage. That's signs of clipping. I go back. Wow, more than 90 volts. It says 96 volts. Let's be fair and calculate with 94.2 volts. That's almost unbelievable. The amplifier delivers 284 watts of continuous power into a 4 ohm load per channel, both channels driven into full power. That's the most underrated amplifier I ever had on my bench. 50 Hz continuous power test, and let's give input signal until clipping. No clipping. Still no clipping. Clipping here. I go back a little bit. That's okay. I calculate with 93.6 volts. That's more than impressive. Even with 50 Hz, the amplifier delivers around 280 watts into a 4 ohm load per channel, both channels driven. Let's have a look at the efficiency. I'm using a clamp meter. Now I give full input signal. Let's have a look. 56.9 amps. That's really impressive. I calculated an efficiency of 73.2%. Now I'm testing for dynamic power, 1 kHz, 20 cycles. I just want to have all cycles at the same voltage level. Now I check this last cycle out and try to increase my input signal. Oh, clipping. We can use this one. We have also 94 volts, so there's no dynamic headroom at 4 ohms per channel. Now I'm testing for dynamic power with 8 milliseconds. I observe the last cycle. No clipping. Clipping here. So we have, it says 97.2 volts. Let's go to the top. We have 94.8 volts. With 8 milliseconds, I get around 288 watts. Short term 1 millisecond power. And you see we have some distortion here. It says 98.4 volts. Let's calculate with 97.2 volts. For just 1 millisecond, the amplifier delivers 302 watts into a 4 ohm load per channel, both channels driven into full power. 50 Hz, 10 cycles. And let's check out the last cycle. We have signs of clipping. That looks quite clean. So it says 94.8 and we are at 94.2. The amplifier delivers also 284 watts. Now I'm going to connect a 4 ohm mono load to the amplifier to get the output power into a 2 ohm load per channel, both channels driven into full power. 1 kHz continuous power test.
Let's go. Wow, clipping. That looks clean. Can we get some more? That's okay. It says 86.4 volts. It looks ugly when I take a screenshot. Let's take 85.8 volts. I got 944 watts of continuous power into a 4 ohm load bridged mono. That means I have 472 watts into a 2 ohm load per channel, both channels driven. And of course, we will have a look at the amplifier's efficiency at 2 ohms per channel. Here's our current. I hope my power supply will survive. 102.8 amps, 7 amps. The amplifier has an efficiency of 67.6%, 4 ohms mono. So we can go and test the amplifier easily 2 ohms mono. I just have to mention that I'm really happy that my small power supply can handle 100 amps with ease and has a voltage of 13.6 volts. Continuous power test with a 50 Hz input signal. Let's have a look what the amplifier can do. Straight to clipping. Oh, clipping. I go back. So it says 85.2 volts. Get to the top. And let's calculate with 84 volts. 452 watts. Now let's have a look at the amplifier's output power with a 50 Hz burst, 200 milliseconds. No clipping. Got to reduce. That looks okay. It says 85.2 volts. Let's calculate with 84 volts. I also got 452 watts. Dynamic power test 1 kHz, 20 cycles. I try to get all cycles at the same voltage level. I try to crank up the signal. Oh, clipping. So we checked the last cycle, it was clip free. Now I'm catching the whole burst. You can see all cycles at the same voltage level and no clipping here. It says 87.6 volts. I would say let's calculate with 87 volts. The amplifier delivers 970 watts, almost 1 kilowatt of output power dynamically into a 4 ohm load. Bridged mono, that means 2 ohms per channel. That's 485 watts per channel into a 2 ohm load, both channels driven into full power. Now I'm performing the dynamic power test with just 8 milliseconds every 32 millisecond burst power test. I observe the last cycle. Let's crank up the signal. No clipping. Clipping here. That's okay. No clipping. It says maximum voltage 90 volts. Try to confirm this. Let's calculate with 87.6 volts. The amplifier delivers almost 1000 watts, mono 4 ohms. I got 984 watts. 492 watts into a 2 ohm load per channel, both channels driven with an 8 millisecond burst. 1 millisecond short burst test. 2 ohms per channel, 4 ohms mono. That looks nice. It says 93.6. Let's be honest. Let's calculate with 91.2 volts. For just 1 millisecond, the amplifier is able to put out more than 1 kilowatt
and it puts out 1066 watts bridged mono 4 ohms. That means I have 533 watts into a 2 ohm per channel, both channels driven into full power. 2 ohms mono test with two 1 ohm resistors connected in series. Dynamic power test, 20 cycles, 1 kilohertz. I just go to the last cycle to make sure it's free of clipping. Oh, goes into clipping. That's clip free. Here's my burst. It says 74.4 volts. It says 72.6 volts. Maybe I got the highest cycle. Yes, let's calculate with 72.6 volts, that's fair. I check out the last cycle. Yeah, let's calculate with 72.6 volts. The amplifier puts out 1318 watts, mono 2 ohms. That means 659 watts into a 1 ohm load per channel, both channels driven into full power. 8 millisecond burst test. There it is. There you have it. Burst, pause, burst, and I go to the last cycle. Check it out if it's free of clipping. Clipping starts here, I go back. Now it looks good. And we have a maximum voltage of, it says 78 volts. I go to the top of the waveform and I'm going to calculate with 76.2 volts. It's outstanding. The amplifier delivers 726 watts into a 1 ohm load per channel, both channels driven into full power, which means it delivers 1452 watts into a 2 ohm load. And now let's check out what the amplifier can put out. 2 ohms mono. For just 1 millisecond, it should have some peak RMS output power. Now we get clipping. I reduce my input signal so it looks okay. And it says 88.8 volts. Let's calculate with 87.6 volts. The amplifier delivers mono 2 ohms, 1918 watts. That means 959 watts into a 1 ohm load per channel, both channels driven into full power for just 1 millisecond. 5 cycles, 50 hertz. That means a base burst signal for 100 milliseconds. I increase signal until it looks bad. Oh, watch this. So maybe this is some kind of protection circuit. I don't know. If I try to give more signal, the first cycles are doing well, but then this happens. Let me know in the comments what it really is. I give more signal. And now the third cycle goes dirty.
special thanks to Sasha for providing the amplifier. Thank you very much for supporting the stuff I'm doing here with my amp dyno tests. Thanks again. If you like this video, why don't you subscribe or leave a thumb? Thanks for watching and see you next time for another amp dyno video. Bye bye.